Hey guys, we are graphing an exponential equation today, okay? If you've been graphing parabolas, absolute value, square root graphs, you're probably used to having a parent graph, right? And then tweaking it a little bit to get your new equations graph, right? So we're gonna be doing the same thing. The only thing that's different is my parent graph could be different for different problems, okay? And let me show you why. So this is kind of what a standard equation looks like, right? For these exponential graphs where there's numbers in for these variables, right? So you'll notice we have a b here, okay? And here b is 2. So it's not always going to be 2. Depending on what that number is going to change what your parent graph looks like, okay? Now, there's usually more than one way to do things in math, right? So what we are going to do to solve this is first we are just going to graph this equation, okay, without any minuses or anything. And then we are going to do the changes, okay? So if you've been doing those other graphs, you're probably used to this. This number being added or subtracted here tells me how much my graph shifts to the right or left, okay? You do opposite of the sign. So this graph is going to shift to the right 6, okay? If I've lost you, hold on. We're going to do it and it'll probably make sense, okay? All right. The number being added or subtracted on the back tells me how much my graph is going to shift up or down, okay? We stick with the sign on this one, so that means my graph is going to shift down 8, okay? So let's go ahead and find that graph that is going to be shifting, right? So we are going to graph y equals 2 times 2 to the power of x. So we are graphing without those minuses, right? And then we will shift them, okay? So we're going to make a table. I bet you're excited. You were like, yes, I was hoping we were going to do a table, all right? We are going to plug in for x, -2, -1, 0, 1, and 2, okay? Now I am going to plug in these for the exponent pretty quickly. If you need an exponent review, if you find I'm going a bit too fast, I'll link a video in the corner for you, okay? But here we go. First, we're going to plug in -2. So when I plug that in, I'm going to get y equals 2 times 2 to the power of x, which we are plugging in -2, okay? Now, when I have a negative exponent in the numerator, I go ahead and put it in the denominator, right? If you're like, what on earth is she talking about? Again, I'll link a video in the corner where I talk about negative exponents, okay? All right, so as I continue to solve this down, I get 2 times 1 over 2 squared, which is 1/4, right? When I multiply that, I get 2 over 4, which simplifies down to 1/2, okay? So when I plugged in -2 for x, I got 1/2 for y, okay? Now we're going to plug in -1. So here, I'm going to draw a little line so this guy's in its own space there. So now I'm plugging in -1. So I get y equals 2 times 2 to the power of -1. Again, it's in the numerator. I'm going to move it down to the denominator. So I end up with 2 times 1 over 2. I could put to the first power, but that's just 2, right? And when I multiply those, I get 2 over 2, which simplifies down to 1. Okay, so when I plugged in -1 for x, I got 1 for y, okay? Now let's plug in 0. So I get y equals, where are we? Right here. 2 times 2 to the power of 0, okay? Anything to the power of 0 is 1. Again, if you're like, this lady's crazy, I don't believe you, I'll link a video in the corner explaining why that is. So as I simplify this down, I get 2 times 2 to the power of 0 is 1. So I end up with just y equals 2, okay? So when I plugged in 0 for x, I got 2 for y, okay? When I plug in 1, 2 to the power of 1 is just 2. 2 times 2 is 4, right? Okay. When I plug in 2, I get 2 squared, which is 4, times 2, which is 8, okay? So there we go. Now I'm going to graph these, okay? So I get -2 and up 1/2, -1, up 1, 0, 2, 1, 4, and 2, 8. okay? These exponential graphs get steep really fast, okay? Oh gosh, guys, I wish I could draw that a little better. There we go. Okay. So they get steep really fast, and also it's going to get closer and closer and closer to this x-axis, but never actually touch it, okay? So this is this graph, right? 2 times 2 to the power of x. So now we need to take that graph, shift it to the right 6 and down 8, okay? And I can do that with each point. So I'm going to start here and go to the right 6, 1, 2, 3, 4, 5, 6, and down 8. 1, 2, 3, 4, 5, 6, 7, 8, right there, okay? Same with this guy. I'm going to go to the right 6, 1, 2, 3, 4, 5, 6, and down 8, okay? With this guy, I'm going to go to the right 6, 1, 2, 3, 4, 5, 6, and down 8, okay? This guy to the right 6, 1, 2, 3, 4, 5, 6, down 8, 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. And then I can do it with this guy, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. I hope you enjoyed hearing me count. Okay, so this is my new graph, okay? It's going to look a little something like that, okay? So my answer is the blue graph, okay? All right, I hope this made sense. We started out with our equation. We graphed it without any of the adding or subtracting. And then we were able to do those shifts right to the right 6 and down 8. Okay, hopefully this made sense. If it helped you, if you could hit the like button, that helps me a lot. Also, if you need some more examples, some more problems, I'll link a playlist for you. Thanks.